Class, what's up? Welcome to our last video actually for 6.1. We're going to recap to help prepare for our quick little quiz next week, all on 6.1. Okay, so in 6.1, a lot of what we talked about was arc length, area of sector. We remember arc length is, of course, fraction of the circumference. Alright, and there's a couple of different ways to write that. Actually, there's a lot of different ways. The two that we like to talk about are s equals theta, and notice I'm putting a degree sign next to theta, over 360 degrees, and then times the circumference, right? So this gets you the fraction that we're looking for, this is the fraction we're looking for, and then times 2 pi r. And then if we're given radians, so notice what I'm doing here, I'm not putting a degree symbol by theta. Well, that tells me that I need to put it over 2 pi. And when I do that and multiply it by 2 pi r, you could, of course, remember s equals r theta. Okay? So, guys, again, the idea that I want you to understand and comprehend and be able to replicate is this idea. It's a fraction of the circumference. Anytime we're looking for arc length, we want a fraction of the circumference. And very similarly, when we talk about the area of a sector, we're looking for the fraction of total area. Alright, again, and actually, you know what, I should have done this. Let's do this. I'm going to draw this in. This is, wow, that's a good picture. This was S. And that's the area, okay, area of a sector. Alright, so our formulas are going to look very, very much the same. It's still a fraction, so theta degrees over 360 degrees, but now we're multiplying it by total area of a circle, which is pi r squared. Or if we're given an angle in radians, so there's no degree symbol, then you're going to put it over 2 pi. Because that's what we know a full circle is, 2 pi radians. And pi r squared. Alright, so if you want to memorize, you can say that area is 1/2 r squared theta. Okay? Alright, so that is a good little introduction or reminder about arc length and area of a sector. We need to go over some things about linear speed and angular speed. That will help us be able to do our unit conversions. So just remember, if you see mph, that stands for miles per hour, or if you see kph, that's kilometers per hour, and then we know something like this might be meters per second. Okay, again, linear speed, this is land speed. Angular speed, this is talking about how fast it goes through an angle, okay? So speed goes through an angle. Cool. So we have things like degrees per second. How many degrees does an object spin per second? Or how many radians does an object spin per second? Alright, so there's our angular speed. When we get into revolutions, we know that RPM stands for revolutions per minute, or revs per min, however you want to write it. And then the ways that we think about revolutions, there's 3 ways. 2 of them have to do with angles, 1 has to do with length. Alright? So let's do the length one first. We know that 1 revolution will always take 2 pi r units. Alright, this one has to do with the length. And we know this because this is just circumference, right? 1 revolution, all the way around, would be the circumference of a circle. Now, if we change this up and we start thinking about degrees, we can say that 1 revolution is 360 degrees, or 2 pi radians. And these we would both want to just remember that those have to do with angles. All right? So now that we've recapped some of those notes, let us go into these example problems. All right, so we have one of these world problems or Earth problems. So I know I'm going to draw a little cross section of my Earth, and I know that I have a city in West Virginia at 38 degrees 21 minutes. So I will draw that right here, and I'm just going to put a WV for West Virginia. And then I know that I have another city in Florida at 30 degrees 20. Okay, so that's actually lower in this case. Sorry, they gave them to me in a little out of order. Alright, so I would draw something like this. Now what we need to remember is, and I know this isn't quite to scale, but like this is the angle measure to Florida, this is the angle measure to West Virginia, and we want this arc length, which means we need this central angle. This is the central angle that we're looking for. That's the theta we need. Hopefully that makes sense. If we're looking for this arc length, then we need that angle. And to do that, then, I'm going to subtract the angles from one another. I'm going to say I have 38 degrees 21 minutes minus 30 degrees 20 minutes, and that should be 8 degrees 1 minute. Alright? Give me 1 second. I need to grab my calculator. Sorry, guys. Alright. Alright. Sorry about that. Alright. I got my calculator now. Now we're ready to go. Now we know, and we have to kind of make the connection, and we already kind of did, but we're looking for arc length. So we know that we're going to use S equals the theta, 8 degrees 1 minute, and because this is a degree, then I want to put it over 360 degrees. And then times 2 pi radius of the Earth, 3,960. Guys, don't even worry about trying to simplify this. Just go to the calculator and remember what we're going to do. Let's see if I can find a good spot. Nope. Okay. Alpha y equals, I'm going to go 8 degrees 1 minute over 360, all times 2 pi 3,960. Alright? It's as easy as that. So you type it out, you hit enter, you get your answer, and we are good to go. So 554.07, 554.07 miles. Okay? And we're on to the next page. Alright, let's do a few more problems and then we'll call it a day. Alright, so we have an object traveling around a circle. We know the radius of the circle. Okay, so I'll draw this. Okay. We also know that in 9 seconds the object travels 3 feet. And we want to know the angular speed. Alright? So I know this is a little goofy. This is a little different than what we've given you in the past. But you know 9 seconds and you know 3 feet. So I would hope that we can make the connection that we have feet per second. And we want to go to radians per second. Okay? Well, that's great. The seconds are already the same, so we don't have any work to do with seconds, but we got to somehow get feet into radians. So let's take a look at this. Now notice, we had 3 feet per 9 seconds, so I'm going to write it just like that. 3 feet, and actually my bad, let me make my bar. Alright, 3 feet per 9 seconds. Now we need to start trying to convert feet into radians. Well, feet is a length, right? And we need to get into angles. Radians are angles. So we actually need to do 2 steps here. We need to first get from feet into revolutions. Alright? Because we can't really go straight from feet into angle. We need to go from feet to revolutions, and then we know how to get from revolutions to angles. So, I know I'm going to want revs. I'm going to cancel out feet. And I know that in 1 revolution, it will go 2 pi times r, 2 pi r, because that is the circumference. So now I'm able to cancel out feet and feet. Last thing we need is we need to understand that if we have 1 revolution, there are how many radians in 1 revolution? Well, we just did that on the other page, 2 pi. There are 2 pi radians. So now we can cancel out revs, and now we have seconds, radians. That's exactly what we wanted. It's time for the calculator. So when we go to the calculator and we type this all in, remember it's easiest to do it as a big fraction. I'm going to put 3 times 2 pi in the numerator. I'm going to put 9 times 2 pi times 7 in the denominator. I'm going to hit enter. Oh, did I do that right? Yes, okay. So we get 1 over 21, and that is radians per second. And that should make sense, guys, because if you think about it, traveling 3 feet in 9 seconds in this big of a circle should not go very far. So 1/21st radians, that sounds about right. All right, couple more. We have a bike. All right, we know the wheel of the bike is 20 inches, so I'm going to draw it. Ooh, be very careful now. The diameter is 20, so that means I'm going to put what? I'm going to just put 10 inches for the radius. And again, it looks like we're given linear speed. We're given miles per hour. All right, and we want to know how many revs per minute. Okay, so miles per hour into revs per min. We know what to do. This is just a big unit conversion. All right, so I'm going to make my bar, start here, and I'm going to write what I'm given. I'm given 19 miles per hour. If you want to put 1, that's fine. Normally, I would suggest converting time first, just because it's the easiest. And we know that we want minutes in the denominator, which means I need to go hours to minutes. And of course, we know that conversion is that in 1 hour there are 60 minutes. And now our hours are canceled. Minutes are what we want. Perfect. Okay. Now we need to convert 19 miles basically into revolutions. Alright, so let's see here. This is interesting. Yeah, I think we might be in a little bit of trouble. We have inches as our radius, and we're given miles. So I think we have some work to do first. Let's convert these miles down into inches. So that'll look like, we know that we can go 1 mile, and there's how many feet? 5,280 feet in 1 mile. So miles cancel. And we also can go 1 foot is 12 inches. So now feet are canceled. Okay? So now we're getting really close. We're really close. I need to extend this a little bit more. Sorry, let me put that in black. The last thing I need is I need to now say that I know that I can convert from inches into revolutions, because I know that the circumference, or in 1 revolution, there is 2 pi times 10, and that's in inches. So now inches cancel, and I'm left with minutes and revolutions, which is exactly what I wanted. So we go to the calculator. We go 19 times 5,280 times 12, and that looks good for the numerator. And then in the denominator we need a 60 and a 2 pi and a 10, and we get 319.33. I'm going to round to 2 decimal places. 319.33 revolutions per minute. Okay, So guys, I would say on this problem, the trickiest thing, the thing that you have to look out the most for, is that these units didn't match, the miles and the inches. All right? We can't just jump from miles right into revolutions because we don't know that conversion. All right? We know inches into revolutions, not miles into revolutions. Okay, so hopefully that makes sense that you need to get from miles to inches before you can go into revolutions. All right? All right, last problem. Let's see here. Excuse me. Find the area of a sector of a circle of radius 17 meters. Oh, nice and easy. All right, I will draw this picture just so that we can see. All right, we know the radius is 17. Pi over 4, I know just from kind of working with angles a lot, that'll probably look something like that. And now we want the area of the sector, right? So let's see here. This is what we're looking for. And we know that we want area. So what is our area formula? It's the fraction of the total circle. Fraction of the total circle. So if I'm given an angle in radians, that means I'm going to do what? I got to put it over radians, 2 pi. 2 pi radians in a full circle. So now we have the fraction aspect of this piece compared to the full circle. And lastly, we multiply it by pi r squared. All right. So what happens? I mean, if we want to work through this, we can cancel out some pi's. We can put, well, 4 divided, okay, so a equals, let's just keep going with it, pi over 4 over 2, and then we have 17 squared. Guys, I'm not even going to mess around with this. I'm just going to go right to the calculator. All right. So let's do it. Alpha y equals fraction. We're going to actually do another fraction. And so now in this top fraction, I have pi over 4. That's all over 2. And then we're multiplying that by 17 squared. And when we hit enter, we get 113.49, and that would be in, what do we have, meters? So meters squared. Guys, one thing you can do if you want to try to get an exact number, you could redo this problem, and instead of putting in a pi, just leave it blank. Okay, keep that as a 1. When you hit enter, you get 289 over 8. So 289 over 8, and then you just need to remember that the pi, we basically took the pi out, right? We need to multiply the pi back in. So that would be the same answer. Okay? All right. That should do it for our recap. Hopefully you guys are feeling good on this stuff. Of course, we will continue to practice to get you ready for your quiz. Have a good one. Peace.